If you have ever used PyTorch, you probably have written this softmax function and moved on. But softmax is everywhere in classification, attention, mixture of expert. So it's important to understand it from scratch. Today, we are going to build softmax completely from scratch, and more importantly, we will understand how it works. Let's start with a list of numbers. These are called logits. These can be negative, don't sum up to 1, and these aren't probabilities. But in many ML systems, we need a probability distribution. All values should be positive, sum should be equals to 1, and larger the input, larger the probability should be. So how do we convert these real numbers into probabilities? That's what softmax does. Softmax has two steps. First step is to exponentiate. We apply this exponentiation. Why exponent? It makes everything positive. It preserves the ordering. It amplifies the difference. If one value is slightly larger, exponentiation will make it noticeably larger. This is important in attention and routing. Small logit difference become meaningful probability differences. Next step is to normalize. Now we divide by the total sum. This ensures all values are positive and the total sum is equals to 1. So softmax is simply exponentiation with normalization. That's it. Now let's see this numerically. We start with our input vector. Step 1 will be to exponentiate each value. Now all numbers are positive. We will compute the sum. This gives us normalized constant. We will divide each value by the total. Now every number is positive. Total sum is 1, and larger the logits, larger the probabilities. And visually you can see this as probability distribution. Here is the naive implementation of softmax. Here we are exponentiating everything and then dividing it by the sum of all the exponentiated number. Mathematically it's correct, but there is a problem. This implementation is numerically unstable. Imagine this as input 1000, 1001, 1002. So this overflows. You will get infinity, and once you have infinity in your tensor, your model is broken. So what do? We will subtract the maximum before exponentiating. This is a more stable version where we are actually subtracting the maximum value from the exponentiated number. And this works because subtracting a constant from every element does not change the final probability, but it prevents the overflow. This is how every ML framework implements the softmax. Now you know how softmax works. Exponentiate, then normalize, and then get the probabilities. In the next video, we can go deeper into temperature scaling or softmax gradients. If this helped you understand softmax at a deeper level, let me know, and I'll see you in the next one.